And now, coming to you live from somewhere over central Canada, Pre-Calculus Math 10. Dance. 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 Today, solving systems of linear equations by substitution. Alright, well, last class we learned that the solution to a system of equations is the ordered pair xy that satisfies both equations. We learned to solve that system by graphing it or by reading a graph, and today we want to look at an algebraic solution. So the problem with solving either of these equations is that they have two variables, so that even if you isolate y in the first equation, for instance, you still have y equal to something in terms of x. But this can actually be quite useful. You see, taking the first equation, we can isolate y by subtracting 2x from both sides, giving us y equals 4 minus 2x. Which, as I say, is actually quite helpful because if y does equal 4 minus 2x, then why don't we just replace y in the second equation with 4 minus 2x? This would give us 2x minus 5 times 4 minus 2x equals 16. And if you look at this, we now have an equation only in terms of x, and we learned how to solve that at least a year ago, maybe even sooner than that. So solving this would be 2x minus, let's expand this first, minus 20 plus 10x equals 16. So we'll have 2x plus 10x giving us 12x. Add 20 to both sides and we get 36. Now isolate for x, divide both sides by 12, and we will get x equals 36 divided by 12 is 3. What we want to do now is find the corresponding y value. How do we do that? One more step of substitution, because if y is equal to 4 minus 2x, let's let x equal 3. That would give us y is equal to 4 minus 2 times 3, which would give us y is equal to 4 minus 6. So in other words, y equals negative 2. Now we can go ahead and check just to make sure that this solution, x equals 3, y equals negative 2, is actually going to work. Check the first equation. 2 times 3 plus negative 2. That is 6 minus 2, which is 4. That's what it's meant to equal. Works in the first equation. Now check the second equation. 2 times 3 minus 5 times negative 2. That gives me 6 plus 10, which is 16. That's what it's supposed to equal as well. Therefore, I can say confidently that the solution is the point 3, negative 2. And we've got this thing solved. Let's review then. What were the steps that we used for solving by substitution? Step 1. Isolate a variable in one of the equations. It could be x or y, it doesn't matter, but choose wisely. Step 2. Substitute this value into the other equation and solve for the remaining variable. Step 3. Substitute your solution from step 2 into the equation you used in step 1 and solve for that variable. Step 4. Always check your solutions in both equations. Again, the key to a system is that your solution has to work in both equations, not just one of them. Let's try another one. Solve. 2x minus 7y equals negative 1, and x plus 4y equals 2. So isolate one of the variables here. It wouldn't make sense to solve for 2x in the first equation, nor would it make sense to solve for y. Isolating x and y in that equation is going to introduce fractions and it's going to get ugly. Likewise, in the second equation, isolating y it wouldn't be hard, but it wouldn't be as easy as isolating x. So whenever you're doing substitution, choose the easiest variable to isolate for so that you don't unnecessarily create fractions in your working. So let's take the second equation and rewrite it as x equals 2 minus 4y. Go ahead and subtract 4y from both sides. So now we'll take this 2 minus 4y and substitute it in place of x in the first equation, since that's what x equals. This will give us 2 times 2 minus 4y minus 7y equals negative 1. Simplify and solve for the remaining variable, which in this case is y. 2 times 2 is 4. 2 times minus 4y is minus 8y. We have a minus 7y equals negative 1. This gives me 4 minus 15y equals negative 1. Isolate for y, I'm going to have to subtract 4 from both sides. This gives me negative 15y equals negative 5. Divide both sides by negative 15, I get y equals negative 5 over negative 15, which I can reduce. First of all, negative over negative is positive, and 5 over 15 is 1/3. So we've got a solution for y equal to 1/3. Let's take this value for y now and substitute it back into this equation so that we can calculate what the value of x is. So we'll have x equals 2 minus 4 times 1/3. Okay, we've got some fractions, but it's not so bad. This gives us x equal to 2 minus 4 times 1/3 is 4/3. What is 2 minus 4/3? Of course, we could rewrite 2 as a fraction over 3. This is 6 over 3. 6/3 minus 4/3. Hey, we know that x must be equal to 2/3. Okay, and now we'll want to go ahead and check this. So we will check 2 times 2/3 minus 7 times 1/3. This gives me 4/3 minus 7/3, and that is negative 3/3, or in other words, negative 1. Checks out for the first equation. Let's check the second equation now. I'm pretty sure it will work, but I want to verify this. 2/3 plus 4 times 1/3. This is 2/3 plus 4/3. This gives me 6/3, which is also 2. That's what the second equation is supposed to be equal. So we know that the solution is the point 2/3, comma 1/3. Don't put it as decimals, no rounding off or anything. These exact fraction values. Well, it's getting to be about that time.
2 for you!
Here's a couple of systems of equations. That's all we've got time for today, so stay tuned and we'll see you next time. Bonus content.